first set of questions, and we have to see if we can find a bias in them. Okay? Do you think people who smoke should be allowed to pollute the air in public places? So if I'm doing a survey and this is my question for you, where's the bias in this question?
About polluting the air, they could just ask if they should be allowed to smoke in public.
That's right. So if we look at that part that is the polluting the air, whoa, that's not what I wanted to do. There we go. That's a negative connotation, right? How could we reword this? Like you said, just take that part out. If we take that part out, do you think people should be allowed to smoke in public places? Now there's no bias in the question. Now it's completely free up to the person answering whether they agree or disagree. Okay, so in your notes, there's a place where you can write down the bias and you can write down the rewording. That was I was stepping on, but it didn't pop. It looks like it should pop when you step on it, but
What is that?
it's just air bubbles. Staple it? Okay, here we go. Do you think homework is a good thing as it gives you the chance to practice what you've learned in class? Okay. That's the bias. It's saying it's a good thing. Oh, no, but it asks you think, but the part that it says, because it gives you a chance, right? Right? Do you think homework is good or bad? Would be a nice rewording of this. I've got another rewording here. Do you think homework is a good thing? A little bit of a bias there because of the good, right? So what do you think of homework? Is it good or bad? Would be even better, because then you're not biasing towards one or the other. So if you want to write it in your own words even better, that's great. Since too much grease can cause a stomach ache, do you think it's good to eat at McDonald's?
Do you think it's good?
Yeah, that too much grease is definitely the bias leading you to think that you should say no. Oh, I had 2 junior chickens last night. And how could you reword it? Do you think it's good to eat at McDonald's? Perfect. I had to add the word you. I don't know. Doesn't sound very good if it's do think. You can also have biases in graphs. So when you're reading the newspaper or reading an article online and they put a graph, sometimes the article wants to influence you in a certain way. Okay? So here we have 2 rock concert attendance graphs in Winnipeg, Regina, and Calgary. We have graph A and graph B. Now the interesting thing about both of those graphs is they say the same numbers. In other words, if you look at graph A, you look at Winnipeg, It says number of people in thousands that went to the rock concert. It's just over 30,000. If you look at graph B, number of people in thousands for Winnipeg, it's just over 30,000. Okay? Regina is 25,000 in this graph. It's about, yeah, it's also 25. I guess it's supposed to be 26. It's the same. This one matches up to the same number. And in Calgary, this is up at 36, and sure enough, or it matches up perfectly as well. So the numbers are the same. Okay? Now, if you want to bias someone, maybe you want to bias the band. You say, look at the chart. You shouldn't go play in Regina. Which graph would they be showing them? Graph B. Doesn't graph B look like Regina's? Yeah, they have, so I circled it here. You see this little squiggle or break in the graph? That means they jumped from 0 to 26, but they can really make something look small just by changing the scale. Doesn't it look like Calgary has way more? Well, they do have quite a bit more, but not as bad as it seems. Right? They're not lying to you, but they are introducing a bias by how they make the graph. Graph B makes you think that Regina is much, much worse than graph A. So if you wanted to explain it in your own words, you could maybe point to this part and say that that break in that graph makes it appear that Regina has so much fewer than Calgary. So here we have two graphs. One says government payrolls up. And the second one says government payrolls stay the same or are stable. You know what the interesting thing about these two graphs? They're the same. Do you see the big difference though in the scale? Right? This one jumps from 19,500,000 to 20 million in a big gap. This would really influence you to say, hey, how come the government is making so much more money right now? That's not fair. I'm a taxpayer. I don't want those people making that much more money. Okay? But when you look at it in a scale like this, it looks the same. Right? So this is the government graph they put out, and this is the graph that people who are mad at the government put out, and then you have an argument. And they're using the same numbers to argue different things. What's some other things that we can think about here? It says government payrolls. Do you think this is for one person? No. Probably not very many people are making 19.5 million in the government. Otherwise, we'd all want to become politicians. Okay? So it's probably a bunch of people. And so then the other thing you have to consider is if it went up, and it looks like it's gone up like $500,000, if that's for 100,000 people, that means everybody got a $5 raise. That would be a totally different thing to argue as well. Could you really get mad at the government if you said, oh, everybody got $5 raise? You're like, an hour? They're like, no, over the whole year. You're like, oh, sucks to be them. That doesn't seem like very much, $5 for a whole year. We don't know, but it does say, no, maybe this, it does look here that these are months, so you get $5 more a month. Wow, that's one more trip to McDonald's, eh? But if you wanted to argue, look, it went up $500,000, well, that makes a big difference. Okay? The other thing that these two graphs do that are different is this one writes 20 million as the number, and this one writes 20, and then on the side it says millions of dollars. It's the same thing, right? But when you look at the one from the right, it looks like, oh, it went from 20 to like 20.5. You're counting in smaller numbers when you're just thinking 20 to 20.5 than when you're thinking 19.5 million to 200 million or 20 million. Those numbers are bigger. That also could influence you. So it takes a moment to write down some of the ideas that we talked about on how there's some bias in these graphs. Canada-wide math tests. These are two different graphs. One says content, one says problem solving. As far as the scale goes, right? Scale goes from 0 to 100, so they're not trying to bias you with the scale. That looks pretty good, okay? What do we've got? We've got Canada, Manitoba English, Manitoba French for 13-year-olds and 16-year-olds, and then 13 and 16-year-olds here. For the most part, this is an example of fairly good data, although there are some biases in this that are a little bit harder to see, okay? First of all, some of the things you'd look at is you'd say, hey, everybody who speaks French in Manitoba is smarter than everybody who speaks English. Is that necessarily the case? No. But it might be that this causes you to think, well, how are those school systems different? Right? You might look at things like, well, if you aren't attending school, it almost always happens that you get moved from French to English. If you're in French but you stopped going to school, then they switch you to English. If you stop going to school, are you going to do better or worse on math tests? Worse. So what does that do? It sometimes takes someone who wouldn't do well because they were in the French school. Now they move them to the English school, and now the French school's marks go up and the English school's marks go down. That could be a possibility, right? And so sometimes, even though there's results, we can't necessarily say, oh, you should really take math and French because you're going to be smarter. That's not necessarily the case. But there are some influences in the background. Then you also look at, well, why is the Canada average better than the Manitoba average? And so even though the data may not be biased in how it's shown, you have to understand how things were marked. What was the situation behind this? And the graph doesn't necessarily tell you that. In the United States, they do testings. And in some parts of the United States, the schools get more money for their education based on the results of those tests. So if your kids do bad, they don't give you money. If your kids do well, then they give you money. Well, this caused a whole bunch of problems. Heard of some schools who, on the test day, a certain group of students went on a field trip and couldn't write it. Is that fair? Does that change the results? Right? If they say, okay, we're going to get our school funding, you have to do a test that has math, English, and history. That's your test. And on that day, they take all the students that have the lowest marks in the school and they say, you guys are going to the zoo. And they did this in some places. And then what happens? All the people that normally would have low scores weren't writing the test, and the school got a better score and they got more money. But is that true of how their school would do? No. So we have to be careful of these biases in the background. Company salaries. 1952, first 9 months, last quarter, first quarter. Okay. Notice this one has the break in the graph again. They jump from 0 all the way up to 3.1 million. What are they trying to show? They're trying to show a big increase. So that break in the graph is a bit of a bias. It's probably not as big of an increase as it looks. If we look underneath, we try to understand what these words mean. It says first 9 months, last quarter of 1952, first quarter of 1953. Okay? It's pretty easy to see that this bar is 9 months. Right? How long is this bar? How much time is this one? How much time is this one? Do you understand what it means when it says underneath first quarter? How much is a quarter of a year? How many months? 3 months. So that's another thing in this one that is a little bit of a problem, is this one's 9 months and the other ones are 3 months. It's not the same. They should probably have all of the data being the same amount of time. Okay, but they're really trying to show a big increase. Okay. So these are 3 ways to measure averages in statistics. So the mean, I'm going to say it's like your normal average that people think of when you do an average. You add up all the items and you divide by your number of items. So for example, if you got 50, you can write it on the mean median mode at the bottom. Just put the definitions right at the bottom. So your mean, median, and mode are the ways of measuring averages. Your mean is your normal average. It's like you got 7 out of 10 on one test, 8 out of 10 on the next test, 9 out of 10 on your next test. What's your average? You would add 7 plus 8 is 15, plus 9 is 24. You had 3 tests. You divide by 3. Your average is 8. 8 out of 10. So you take all the items you have, add them up, divide by how many you have, and that's your average. Your median, second definition, is the middle number or the average of the 2 middle numbers. And we're going to do some examples. But if you had 5 numbers, 1, 5, 6, 9, 10, the middle number is the 6th one. But if you had 6 numbers, 1, 2, 3, 7, 10, 12, if you had 6 numbers, the middle is right here, 3 on either side. So you would say you have 2 middle numbers, and then you would figure out what is the average of those 2 middle numbers. How do you find an average? You add them up. 3 plus 7 is 10. Divide by 2. The average of 3 and 7 is 5. So the median, wow, I spelt it wrong. Not medium, median. The median is the middle number or the average of the two middle numbers. And finally, the last thing we look at in statistics is the mode. It's the number that happens the most. Okay? So our first example on the thing that I handed out, it gave you the numbers 2, 5, 9, 7, and 7. The first thing that you're always going to do in these questions is take the time to rewrite them in order. So the order would be 2 first, then 5, then 7, then 7, then 9. To calculate your mean, you would go to your calculator and add them all up. So 2 plus 5 plus 7 plus 7 plus 9. If your calculator is working. Oh, did it? It's just there. 2 plus 5 plus 7 plus 7 plus 9. If I add them all up, it adds up to 30. We have to divide then, after we've added them up, divide by 5, and find out that our average, or our mean, is 6. Your median, well, we have 5 numbers. Which one's in the middle? Or is there 2 middle ones? Okay. 2, 5, 7, 7, 9. Which number's in the middle? 7. The 7. Which 7? The first one. Okay. Can you see that that's the middle number? There's 2 on the right-hand side, 2 on the left-hand side. If you have an odd number, there will always be a number in the middle, right? There's 3. I could show you the number in the middle, but it might be inappropriate. I'll put it down instead of keeping the other ones up. Okay? Right? That's the middle one. When there's an odd number, you always have a middle one. When there's an even one, there's not a middle one because you have 2 on either side, nothing in the middle. So then you have to find the average of those ones in the middle. Yeah, try that. It took me a long time to practice to do that. This, and then this, and then this, and then this. Can you keep your fingers together? Yeah, here. Anyways, the median is 7. The mode, is there one that happens the most? 7. Perfect. Let's do another one together. Second example is 5, 9, 5, 5, 9, 5, 3, 7, 6. So we start in question 2 by rewriting. The first is a 3, and then there's 5 4 times, 6, 7, and then 2 9s. One of the things when I rewrite them is I count them after I've rewritten them. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I count on my paper 1, 2, 3, 4, 5, 6, 7, 8, 9, just to make sure I haven't missed a number. Then I go to my calculator. I add them up. I'm using the order of my paper, 5 plus 9 plus 5 plus 5 plus 9 plus 5 plus 3 plus 7 plus 6. Push enter. The whole thing adds up to 54. I had 9 of them, so I divide by 9. My mean is equal to 6. We counted that there was 9 of them, so that there means there will be one in the middle. Which is the one in the middle?
5.
The fifth one. 1, 2, 3, 4, 5. This is your middle one. 4 on this side, 4 on that side. So your median is 5. Which number happened the most? I find the definition for mode is easy to remember if you think of the word most and mode. They kind of go together that way. Let's do 3 together, and then you can work on your own. Okay? So question 3. Okay, I'm going to rewrite them in order. The smallest number is 2. We have 3 2s, then 1 3, then 5, then 8, and 2 9s. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. So I double check that I wrote it out. I'm going to go to my calculator and add them up. So 8 plus 5 plus 2 plus 2 plus 9 plus 2 plus 3 plus 9. Enter. 40. We divide that because we had 8 of them. Okay? If these were your test results out of 10, you've got 50% right now, 5 out of 10. So the median, or sorry, the mean, that's the average we just figured out, is equal to 5. This time, and this is the reason I wanted to do this last one together, this time we have 8 things. Whenever you have an even number, there's not going to be one middle value. In fact, the middle is going to be right here in between with 4 on the right, 4 on the left. So then, to figure out your median, you have to find the average between 3 and 5. Okay? This is one you could probably do in your head. What's between 3 and 5? 4. Okay? But if you wanted to use your calculator, same idea. How do we find an average? We add them up. 3 plus 5 is 8. We have 2 things. Divide by 2. And we get 4. Although this one, a lot of people do with mental math and just say, what's in between 3 and 5? It's 4. Easy enough to figure out. And the mode? 2. 2 happens the most. So here is practice with mean.